Have you ever designed a circuit board that looked absolutely flawless on your screen and on paper? But when it hit production and real-world testing, it started acting weird, resetting, or just failing completely? As the operating frequencies of digital systems rise and signal edge rates get faster, electromagnetic interference, or EMI, has become one of the biggest challenges in modern PCB design. Today we are going to break down 5 common mistakes in high-speed routing. If you ignore these, they will cost you expensive redesigns and failure in standard compliance tests. So, stick around until the end of this video. Mistake number 1. Poor grounding strategy. High-frequency signals always choose the path of least impedance for their return. When you design a fragmented or discontinuous ground polygon, you force the return current to take longer, irregular paths. This means an increased loop area and, consequently, severe electromagnetic noise emission. As much as possible, use continuous, gapless ground layers, and never route high-frequency tracks over splits in the reference layer. Maintaining an integrated, solid ground plane beneath sensitive signals guarantees your system's stability. Mistake number 2. Excessive trace lengths and sharp angles. At high frequencies, the tracks on a board are no longer just simple electrical connections. They behave like electromagnetic waves. A long trace can act exactly like an antenna, meaning it can both absorb environmental noise and emit noise itself. Furthermore, using sharp 90-degree angles in certain applications causes impedance discontinuities and signal reflections. Keep the paths of high-frequency lines as short and direct as possible. Use smooth 45-degree bends or arcs, and completely isolate noisy sections from sensitive analog or RF areas. Mistake number 3. Violating differential pair principles. High-speed protocols such as USB, HDMI, or Ethernet rely on differential signaling to eliminate noise. However, this capability comes with one major condition: symmetry. If the spacing between these two lines constantly changes, or if the length of one trace becomes longer than the other, common mode noise rises drastically. This imbalance destroys the noise immunity properties of the lines and turns the board into a noise transmitter. Maintaining a constant spacing, precise length matching of both lines, and minimizing the number of vias are the golden rules of differential pair design. Mistake number 4. Poor decoupling of the power distribution network. During switching moments, high-speed ICs draw sudden, sharp currents from the power supply, which causes voltage fluctuations and generates high-frequency noise on the power plane. If decoupling capacitors are not properly positioned close to the pins, these fluctuations spread across the entire board and emit severe noise. Always use multiple capacitors with different values to filter various frequency ranges, and minimize the distance between the capacitor and the IC's power pin to maintain a stable, low-impedance PDN. Mistake number 5. Bad management of vias and layer transitions. Every via you place on the board introduces unwanted parasitic inductance and capacitance, which disrupts the path's impedance. Even worse, constant layer transitions cause the return current to lose its path in the ground layer, leading to a severe increase in radiation and crosstalk. Minimize the number of vias in high-speed paths, and always use ground stitching vias next to the signal via to maintain the continuity of the return current path. Success in high-speed PCB design goes far beyond just connecting a few components together. It requires discipline, an understanding of electromagnetic field behavior, and adherence to layout principles. By avoiding these 5 mistakes, you will design highly stable boards that easily pass strict compliance standards. If you are currently working on an industrial or high-frequency project and need simulation, EMI analysis, or a complete redesign, our team is ready to optimize your projects with guaranteed stability and test compliance. Get in touch with us through our website,